Saxon's Calculus, lesson 88, is about asymptotes of rational functions. So we're basically looking at messy fractions. So example 1 on page 432 says, find the equation of the horizontal asymptote of y equals 4x to the fourth, sorry, that's not really legible, plus 3x squared plus 2x. And I know where I'm headed, so I'm going to leave a little gap here. 3x to the fifth plus x cubed minus 4. All right, so if I look at and I see that I have more exponents here as its highest than I have on the upper one, then I'm going to take and divide everything by this first piece like we've done in earlier lessons to unlock like our tangents and that sort of thing. So if I do that, then I'm dividing by the x to the fifth part with all of these. And that's why I said I knew where I was headed, so I was going to leave a gap of space so we could do that. So then we will simplify that down to 4 over x plus 3 over x cubed plus 2 over x to the fourth over, those cancel, 3 plus 1 over x squared minus 4 over the x to the fifth. I couldn't make any changes there. So as I picture the x getting bigger and bigger and bigger, these are all approaching nothing, because as this gets bigger, as we just did here, it's getting to 0. So that's leaving me with this 3, but my numerator, it doesn't matter because my numerator approached 0. So 0 divided by 3 is still 0. So find the equation of the horizontal asymptote. So that as an equation would be y equals 0 because it is the horizontal asymptote that they were looking for. Example 2, graph the function of y equals negative 5x plus x squared over 2x squared minus 8. Now, since this is asking for a graph, I would start out by saying I have a dot. It's like I'm factoring this in my head. X pulls out and leaves me x minus 5. So I've got a dot at 0 and I would have a dot at 5. And then where would I have asymptotes in the denominator? If I divide everything by 2, that leaves me x squared minus 4 equals 0. So I would have both positive and negative 2. Positive 2 and negative 2 for asymptote sections. All right, now, we knew that if we divided everything by this highest piece, just like we did in the last example, that would tell us a horizontal asymptote that we might need to graph. So before, at this point, we just picked our values and plugged them in, but now we want to stop and do the other. So that's going to be negative 5 over, and I'm going to try to do this mentally, x over x squared would be just x, plus, and if I divide this by x squared, that's a 1, over 2 minus the 8 over the x squared. And since those are dropping to zeros, I have a horizontal asymptote at y equals a half. So if I put a 1 here, I have halfway as a horizontal. So now I've created section here, section here, section here, section here, section here, section here, that is going to be changing things not fully, but slightly. Okay, so then as we graph other numbers, what I discover is that if I graph 1, 2, like 3, then I get a number down here in the negatives. And the asymptote tells me I'm going to get closer and closer to that one, and I'm going to bound to that one as well. And then I'm going to do this one over here. So if I plugged in -3, I would discover that I get a positive answer, and so I'm going to be bounding by the 2 asymptotes. Now, what's happening in the middle? So if I plug in 1, I get a positive answer, so it's up here somewhere. And if I plug in -1, I get a negative answer. Now, this is not 2 separate sections. This one rides through the asymptote and looks like so. And you can play with those numbers to prove to yourself that that is actually what that does. And part of, well, not part of, the reason that you are allowed to cross this asymptote is because it is close to 0. And when we plug in the numbers here, we get answers that are close to 0. And so that's why it can override through it. Now, example 3. Graph the function of y equals x squared plus 1 over x. Again, since we're graphing, I know that I have whatever I'm plugging in here becomes the asymptotes, like 0, 0, 1, 1, -1, -1. So I'm getting my asymptote line here. And then x squared plus 1 would give me, let's see, I would have a problem there because I can't factor that. So I'm not sure that I have actual dots. So let's go ahead and do and see if we have any other asymptote. And that would give us x plus 1 over x over 1. Of course, that over 1 doesn't matter, and that's dropping off. So basically, we're getting x, so y is approximately x. Oh, well, wait, that goes right back to what I just had here, so it is the same asymptote. Now, I just need to plug in some values. So if I plug in like 2, I get something that's above this line. So I also know that I'm bounded by the y-axis, because I can't have 0 in the denominator. So it's going to be up in here somewhere. And then if I plug in like a -2, I realize that I get an answer that is below this line. Again, I'm bounded by the y-axis, so I'm going to have a curve somewhere in here. Example 4, graph the function of y equals x squared minus 1 over x minus 2. Graphing. So I cannot have, positive 2. That will definitely be an asymptote. And can I factor x squared? Yes, I can factor that to x plus 1 and x minus 1, which means that I am crossing the y-axis at +1 and at -1, the solutions for those. And then if I divide everything, we would get x squared divided by x would be x. Not sure they're doing that because I'm thinking the degrees are backwards. The numerator is the higher one, so that's actually not going to help. All right, so then this one is slightly more complicated because it's backwards from what I was used to doing. So I have to actually work this out, and you could do synthetic division. I think it might be faster. They were doing long division. Let me just see that. So I'm testing separating from the x, so that's going to be +2, 1. I don't have an x term, and -1. Drop that. That would go to 2. Add 2, 4. That would give me 3. So then the equation would be x plus 2, and it has the remainder of the 3, but they're saying that remainder is irrelevant. So I'm just focused on the, because it's approaching 0 again. So I'm just graphing this x plus 2, y equals x plus 2 as my other asymptote line. So that would be crossing the y-axis at 2 and counting a slope of, and I'm going to go backwards, down 1, backwards 1. Yes. And then, oh, I might do it this way, up 1. Okay, so it would land here. All right, so here is then my other dashed line. So I'm creating a section here, 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 and here. Okay, so this one I know has the 2 dots. So it's going to have to jump somewhere in here, kind of like a parabola. And I know as I keep going, it's going to go down and be curved by that asymptote. And as this one goes out, it's going to be blocked by the asymptote. Then that tells me that my other section should probably be up here. So I'm going to throw in number 1, 2, like 3 or 4 and discover that I get a dot up in here somewhere or other. So it's going to be, oh, that was lousy. It's going to be bounded by, there we go. It's going to be bounded by both of those asymptotes.